Hold up.
Good day everyone, I am Valerie Gonzales and welcome to my vlog. Today I will discuss about plant systematics. And now, what is plant systematics? Plant systematic is a branch of biology that incorporates the extant classification of taxonomy, but its main purpose is to reconstruct the development of plant life. It uses morphological, anatomical, embryological, chromosomal, and chemical data to classify plants into taxonomic categories. The science, however, varies the traditional taxonomy in that it anticipates and chronicles plants' evolution. The basic purpose of systematic is to determine phylogeny, or the evolutionary history of a certain group. Plant systematic classification systems are cladistics, phonetics, and phyletics are all methods of categorizing plants. We must first discuss the cladistics. Cladistics is a taxonomic classification system that uses a plant's evolutionary history to put it into taxonomic category. Cladograms, often known as family trees, are diagrams that depict the evolutionary sequence of descent. The map will show which species have evolved from a common ancestor in the past, as well as which species have evolved from the common one through time. Asanapomorphy is a characteristic shared by two or more taxa that was present in their common ancestor but not in previous generations. A phylogram is a cladogram that employs an absolute time scale. Next is the phonetics. To define plants, phonetics uses an overall similarity rather than evolutionary data. Physical qualities and quantities are used, yet physical similarities can also represent evolutionary history. Linnaeus' contribution to taxonomy is an example of phonetics. The last one is the phyletics. It's impossible to compare phyletics to the other two techniques directly, but it's the most natural method because it implies new species emerge gradually. Phyletics, on the other hand, is closely related to cladistics since it clarifies ancestors and descendants. What method does a plant systematist use to search a taxon? Plant scientists might choose a taxon to examine and refer to it as a research group or in-group. Operational taxonomic units, or OTUs, are the individual taxonomic units. How are they going to make the tree of life? Is morphology, physical appearance and attributes, or genotyping DNA analysis the preferable method? Each has its own set of pros and downsides. Unrelated species in comparable environments may evolve to resemble one another in order to adapt to their habits, and vice versa as related species living in different environments. It is increasingly likely that molecular data can be used to make an accurate identification, because DNA analyses are no longer as expensive as they formerly were. However, morphology should be taken into account. Several plant components are particularly valuable for clarifying and identifying plant species. Pollen, for example, can be used to identify plants through the pollen record or pollen fossils. Pollen has a long shelf life and may be used to identify certain plant species. Flowers and leaves are frequently utilized as well. Plant systematics may have been accidentally initiated by early botanists such as Theophorus, Pedanius Dioscorides, and Pliny the Elder, who each catalogued many plant species in their writings. With the publications of The Origins of Species, Charles Darwin became the most influential figure in science. He may have been the first to employ phylogeny, and he referred to the fast evolution of all higher plants in recent geological time as a abominable riddle. Plant systematics is a field of study that focuses on the study of plants. International Association for Plant Taxonomy, based in Bratislava, Slovakia, aims to advance botanical systematics and its importance to the knowledge and value of biodiversity. A bi-monthly journal focused to systematic plant biology is published by them. Systematic Laboratory is located at the University of Chicago Botanic Garden in the United States. They aim to compile precise data on plant species in order to characterize them for study or restoration purposes. They store preserved plants in-house and record when they were harvested, in case it was the last time the species was ever harvested. Become a plant systematist. You could be an excellent plant systematist if you're skilled at math and statistics, can sketch well, and enjoy plants. It also helps if you have good analytical and observational abilities as well as an interest in how plants evolve.